Good morning, good afternoon, and good evening. Welcome to this online presentation on an important MAPI standard called Object and Scene Description. Before talking about Object and Scene Description, I spend a little time on introducing you to moving picture, audio, and data coding by artificial intelligence, or MAPI, which is an international unaffiliated nonprofit standard developing organization, developing AI-based data coding standards, and with clear intellectual property right licensing framework. Now, maybe I should say something more about the data coding standard, because this is our mission. And data coding is about how you represent the data so that they can be processed by a machine. And depending on how smart the representation of data is, your processing can be better, more efficient, faster, whatever. AI is an excellent technology to do that, and this is where we are concentrated. But then we also have the issue of clear intellectual property right licensing framework. So we mean by this that they want to make standards accessible and timely available. So you say, why do you want to make standards accessible? Well, we want to make standards because sometimes they cannot be exploited, or they exist, but they are not timely available. So we want to provide us a help in resolving this, and therefore we have a process that is based on the fact that before initiating a standard, principal members, because we have two classes of members, principal and associate. So the principal members develop and adopt the framework license, a license without values, without dollars, without the percentage, data, business models. But what the license shall contain, is that the license will be issued at a price comparable with similar standard technology and not after products are on the market, to put everybody on an equal footing. During the development, any member making a contribution declares it will make its license available according to the framework license. And after the development, the members holding IP in the standards, and they only, not MAPI. MAPI is completely out of this process, selected the preferred patent pool administrator. So this is what we can do. But then towards about the development of MAPI standards. So developing standard is a serious business, and it should be done with a rigorous process. And our is certainly rigorous because it has an 8-step development process, starting from the development of functional requirements, then commercial requirement, then corporate technologies, the actual development of the standard, publication of the standard for comments from the community before the standard is published, and finally the publication. So what is the general feature of MAPI standard? We make explicit the computing workflow of AI application. So this is a major characteristic, and we do that by breaking monolithic AI application into a set of interacting components that have, as far as possible, known data semantics. Therefore, developers can compete offering better. What is better? That's not our business to say, but that is the claim. We do help in providing some tool to do that, but improve performance standards component. And humans have an advantage because the application they use have an internal operation that can somehow understand. It's not a complete black box that you don't know what it does. So, in summary, MAPI standardization is component-based, where an AI application is subdivided in smaller components called AI modules, aggregated in one or more AI workflows, and executed in a standard environment called AIF. And this is also the name of an important foundational standard for Empire. This figure summarizes this AI framework. As you see, you have AI modules grouped in an AI workflow, executed in this environment, and the controller, of course, oversees the flow of the processing. And we have a set of APIs to help developers developing the applications. We have a second point that it's important to clarify, and that is every standard creates an ecosystem, and the Empire standard are no different. So we have developers developing components according to the Empire standard, integrators assembling components, and consumer that use the assembled components. We have identified the need for an entity called the Empire Store that guarantees that the components and the applications are interoperable, trusted, and available. So this is the goal of this Empire Store, and all this is specified in another foundational standard called Governance of the Empire Ecosystem. So this is the Empire ecosystem. We have Empire, we have implementers, performance assessors, the Empire Store, and end users that download the application and components and may report their experience score. This is our organization. So we have a General Assembly, we have board of directors that performs certain basic functions, but everything important happens in the General Assembly where the members are represented. So you see many yellow groups here and some green group on the other side, and they are actually developing the standard. So we have done something, I believe, and that is that you can see from this table. We have 13 standards that have been approved, actually more than one version. It means that there have been additions, improvements, and so on from version to version. And we have a few that are in italic. It is indicated that are being developed. Then we have also projects that are not reached the development stage because we are still working on functional requirement, comfort technologies, and so on and so on. So let me go to the scope of object description. So it specifies the components, which are the AI modules, and data format. And with that, we can describe and localize unimodal and multimodal objects and scenes and virtual spaces so that different Empire standards can use them for their applications. Object description has one application, which is called the television media analysis. We have an important implementation, open source implementation. If you go to the Empire website, you will see news about it. It's been developed by 4 groups, so this is another feature of Empire, particularly when we have these are standards that can be reused but in a uniform way. So this is important. So we don't want to have a specification that applies for audio and another that applies for another area. Now we want to have, as far as possible, common use, uniform use across our technical specifications. So these are audio, multimodal conversation, portable avatar format, and connected autonomous vehicle are the groups that have contributed to the development of MAPI OSD. So this is the table of contents. The table of content has forward, which tells the context of MAPI. I've already said something. You can find something more. Then we have the introduction that just sets the scene. But the introduction is not normative. It is really informative. Then we have the scope. This is where we mean. So this standard does this. We have definitions. So we when you develop a standard, words are very important. So you must make sure that if I say A, it is understood as A and not as something else. Then we have references, because this is MAPI OSD does not live in a vacuum, so it has a relationship and therefore may need to reference other standards. And then we have what is called here AI workflows, which are the applications, actually only one in this case, AI modules, which are the components, and the data types. Well, these are the data that are exchanged by AI modules and AI workflows. So all this, you will have this PowerPoint presentation accessible on the website, and you can click there, you can navigate the MAPI OSD standard, because this is another feature of current MAPI standard, that they are individually specified in web pages. So we have many web pages. So we have at least 8 web pages, but some have sub pages. So this is some examples of what MAPI OSD specifies. Let's have a look at annotation. This is quite an interesting thing, because it says that, first of all, what is an annotation? Is data attached to an object or a scene? So we also have something that is called qualifier that does a similar job, but unlike a qualifier, which is a permanent description, annotation is something that may vary with time. So this is essentially the difference between the two. And here you have the semantics. So you see that we have an annotation ID. We have information, space-time information about this annotation. Then we have the annotation data. And so this is the interesting thing. You can use anything that is represented by JSON text as an annotation. And then also you will say this annotation is valid in which space and at which time. And yeah, process action will be a long digression, but essentially it is a very simple form of DRM that helps developers to signal whether this annotation is seen by me or but it can be seen by another guy. So that is what it is. And so then we have, I will just show it quickly. In this case, so we have the JSON. So as you see, this is very simple. Okay, let me go back to the presentation. So then we have many others. We have the audiovisual object. We have the audiovisual scene. Then we have the notion of location. This is very interesting, but unfortunately we don't have the time to work on that. We have point of view. What is a point of view? Point of view is positioning and orientation of an object in a virtual space. Selector is something that tells you of the many things that are possible in the system which actually are activated. Visual object. Let me go here because It is another interesting example. So it is an object perceptible by a visual device or visible to a human when rendered. So this is the definition of a visual object. So here you will see that we have, well, the M instance is the ID of the virtual space. Then we have the ID of the visual object. Then we can also say, okay, this visual object has a history behind. It has parents. And so this is specified also here. Then we say the visual object has a space-time information. Okay. It has qualifier. Well, qualifier again would be another big digression, but essentially it is, as I already said the words before, um, it is a collection of data that describes what the object is, and the description is not meant to be used by humans, but is meant to be used by machines. So it helps. It can be used to help you tell the machine exactly what you should do with the data. Then we have the annotation, and the annotation you will see here is done by annotation space-time information, and the process action, because it is what very much the same concept that I have introduced before. So let me go back, and so then we have the visual scene descriptors. Again, it would be another complicated talk, but you know, you find everything, and you know, you have our page for each of these data types. So then, so here I will say something more about the notion of helping AI modules to do a better job. So an AIM can do a better job if it knows more about the capabilities of the AIMs it is connected to and the data it receives. So if we take an example, natural language processing, this is an AIM that is expected to produce text and meaning using 3 levels of information. Just the text is given, and from that, this AIM should improve the recognized text and also extract the meaning that is embedded in the text. Then it can also use the identifier of an object or more than one object. So if I'm talking about something, it is helpful to the AIM to understand the text because I'm giving some hints about what the text is about. Then exactly how this is done, MAPI is absolutely silent. We provide the means to express things. We don't say how you actually express the thing. That is something that is based on potentially proprietary technology. And the other information that we can give is the space, the virtual space where this object is. Virtual, but it can also be used for a real space. So with that, again, if I say at your left and so on, okay, then the natural language processing AIM can understand better the text. So it's a matter of helping. And this is done by profiles because these are features, characteristics, performance of an AIM. And we have to say, if the AIM just receives text and provides text and meaning, that's a simple one. But it also is able to understand and make use the object identifiers. It's more complicated, probably more performance, and therefore you can sell it at a higher price. Same if it also is able to handle the context, the spatial context where the object is located. So then we have the second part, which are these qualifiers that I've talked about already some time. So what is a qualifier? Well, we want to be able to say that this data, for instance, if it is visual data, we want to say what is the color space. If it is a file, say an audio file, we want to say that it is in a wave file, not in something else. And then imagine that you have a speech, and of course, the AIM receiving the speech can do the work of understanding what is the text. But maybe if this was already been done by another AIM, this can be easily communicated. And all this information is added to something that is called a qualifier. That is something that can be used to inform the AIM about specifically the data. So we have identified the three classes. One is the subtype. So for instance, in the case of a visual object, the color space is a subtype. Then the compression of the visual compression can be expressed by format. And you have many, and so you have the means to say that it is this particular coding format that is used by this data. Or it can even describe, so it can be a video, staying in this example. This video has an object, and another AIM has identified this object. Of course, the identification should be shared across the different AIMs in a particular context. But this is again another way of informing another AIM about the data. So all this is done by JSON metadata. I've already shown for data, but this is true also for the AI modules and for the AI workflows. So these are quite a few AI modules that are specified by this object and scene description. So we have, for instance, the audiovisual scene description, and then the television splitting. Television splitting is something that receives a video and audio video and splits in audio and video. It's quite simple. No, you don't need AIN. But if you wanted to understand when a visual scene changes in a video, well, that's not that easy, and the AI can be used. Anyway, we only specify the interfaces, the data in and the data out. We don't say how this is actually done. And then we have this television media analysis that I definitely want to show you, because it's been a major development. So we have the full specification here. And what is interesting is this reference diagram where you see that you have audio and video coming in. We have television splitting that does the job of separating video and audio. Then if we take the video, we have this change detection that I've talked about, providing information. Based on that, there's another AIM that can recognize the face. But if we go to the audio part, we have audio segmentation that provides different speech segments. And for each of them, we can recognize the ID of the speaker uttering a particular speech segment. Then we can go to, we have, again, all the face IDs here, the bounding boxes, and going to audio, we have the possibility to recognize the speech. And so this, again, is another potentially very sophisticated AIM. Then we needed to align, say, we have identified a speech object, but we have to associate it with a face. And this is done by this AIM here. All this flow of information is multiplexed in a JSON by this audio-visual scene description. An audio-visual scene description is the snapshot that describes a scene change, essentially. Then, if you put all these scene description together, you create an event description that can be a 1-hour television program. And therefore, because all this is expressed in JSON, you can easily develop navigation application or other application that use this television media analysis result. So let me go back to the other things, which is again stay in the television media analysis. Here you have an example of how MPI operates, because you see that we have AIMs that bear the multimodal conversation. So, for instance, audio segmentation is developed by the multimodal conversation group. If we go to audiovisual alignment, so this is something that has been done by the OSD group, but we also have another contribution from the portable avatar format group. The name should be clarifying what they are about. That recognizes the identity of the face, and then we have other as well. So what is next? Well, of course, because the world does not stop, and so the MPI does not stop. So MPI OSD is a living standard, and this is in its nature. It serves the needs of many MPI standards application area. And we are already working on a new version that includes new functionalities or improved functionalities for existing elements. At the moment, we don't have conformance testing, so this is one major activity that we are developing. So with that, I would like to thank you very much for your participation in this presentation. And MPI looks forward to working with you on this exciting MPI project. And join MPI because you can share the fun and build the future. And I can tell you that we have a lot of fun. And well, we believe that we are building the future. And here you see how you can access the MPI OSD standard by clicking on this link. Thank you very much for your participation. I stop, but so can you